Hello students, in the previous session we had learned value of a polynomial, zero of a polynomial and geometrical meaning of zero of a polynomial. Let us recall one by one. Value of a polynomial. If I consider polynomial as p of x for x value is equal to 1, the value of polynomial is p of 1. Say for example, if p of x is equal to say 3x plus 2, the value of polynomial for x is equal to 3 will be p of 3, that is 3 times of 3 plus 2. It becomes 11. 11 is the value of the polynomial. Recall zero of a polynomial. Suppose the polynomial say p of x is given by 3x minus 2. The value of this polynomial for 2 by 3 will be 3 times of 2 by 3 minus 2. It will be 2 minus 2 equal to 0. The value of the polynomial will become 0 for x is equal to 2 by 3. Therefore, x is equal to 2 by 3 is 0 of 3x minus 2. This 3x minus 2 is a linear polynomial, so we will be having only one zero of the polynomial. This we have understood by geometrical meaning of zero of a polynomial. We have seen three cases. The first case was for a linear polynomial. The second case was for a quadratic polynomial, and the third one was for a cubical polynomial. Look at these points. It is note for exam. First point is the real zeros of polynomial p of x are x coordinates of the point in which the graph of the equation y is equal to p of x intersects x-axis. We have solved a question wherein different graphs were there. We have understood. Say this type of graph was there. This was y-axis and this is x-axis. We add a line L parallel to x-axis. In this case, number of zeros is 0. We had other type of graph wherein it cuts the x-axis. If this point is say x1 comma 0, the x coordinate is the 0 of polynomial. 0 is x1. 0 of the polynomial is x1. We also had quadratic polynomial of this type. And also of this type. The point where it cuts the x-axis, that x coordinate x coordinate will be the zero of the polynomial. We say real zero of the polynomial. Look at the second point. The graph of the equation y is equal to ax plus b, a not equal to 0 is a straight line if it intersects the x-axis at x1, 0. Then x1 is the only real zero of the linear polynomial p of x. Look at this, y is equal to ax plus b, where a not equal to 0. It is a linear polynomial. For a linear polynomial, always we have a straight line. If this straight line cuts x-axis, suppose if this is a straight line, it cuts the x-axis at this point. If the point is x1, 0, the x coordinate is x1 will be only real 0. Understood? Look at the third point. The graph of the equation y is equal to ax square plus bx plus c, where a not equal to 0 is an upward parabola or a downward parabola according to the value of a. If a is greater than 0, it becomes an upward parabola. If a is less than 0, it becomes a downward parabola. One of the students had asked how to plot the quadratic polynomial. You have to consider different values of x and y and plot those points, and you have to draw a smooth line passing through maximum number of points. We get a parabola. However, in your examination, you will not be asked, I repeat, you will not be asked to plot the graph of a quadratic or a cubic polynomial. It is not for the examination. However, linear polynomial, you need to learn how to plot the graph because it is there in the next topic, next chapter. Linear equation in one variable and linear equation in two variable. It's there in the next chapter. Understood? If the value of a is greater than 0, we get this type of graph, upward. If the value of a is less than 0, we get an inverted parabola. These two are parabolas. Look at the fourth point. If the graph of y is equal to ax square plus bx plus c, a not equal to 0, intersects the x-axis at 2 points, x1, 0 and x2, 0, then x1 and x2 are the two zeros of a quadratic polynomial ax square plus bx plus c. What does it mean? If we have a quadratic polynomial, we get a parabola. Suppose I get a parabola like this. If this particular point is say x1, 0, if the coordinate of this point is x2, 0, then the x coordinate is x1 and x2. So x1 and x2, these are the two zeros of polynomial ax square plus bx plus c. Now tell me, what if the graph is something like this, wherein it doesn't touch x-axis or it doesn't intersect x-axis? Here there will be no real zero. Real zero will not be there. We have also seen that sometimes we get coinciding zeros. We will see in the next point, point number 5. Look at point number 5. If the graph of y is equal to ax square plus bx plus c, a not equal to 0, touches the x-axis at x1 comma 0, then x1 and x1 are two real zeros of the quadratic polynomial. Something like this. If the graph is meeting x-axis at only one point, say this point is x1 comma 0, it means there are 2 points. Because it is a quadratic polynomial, there are 2 zeros which are coinciding at this point. So x1 and x1 repeated equal roots will be there for the quadratic polynomial. Repeated equal zeros are there for quadratic polynomial. Look at point number 6. If the graph of y is equal to ax square plus bx plus c, a not equal to 0, neither intersects nor touches the x-axis, the polynomial doesn't have a real root, a real zero. We have understood this in our previous example. If the graph is something like this, or if the graph is something like this, wherein it doesn't touch or it doesn't intersect x-axis, the number of zeros is 0. Look at point number 7. The graph of equation y is equal to ax cube plus bx square plus cx plus d, where a not equal to 0 intersects x-axis in at least one point, in at most 3 distinct points. So a cubic polynomial has at least one real zero, at most 3 real zero. We have seen different graph in that question. It can be something like this, wherein there are the relationship between the zeros and the coefficient of polynomial. Here again we will take 3 cases. The first case is for a linear polynomial, the second case is for a quadratic polynomial, and third case is for a cubic polynomial. Let me take a linear polynomial. I'll take an example, p of x equal to 2x plus 5. This is a polynomial. To find the zero of polynomial, what we were doing? We were equating this to 0. So we get the value of x as minus 5 by 2. This minus 5 by 2 is the only zero of the polynomial. Observe, zero of the polynomial two x plus 5 is minus 5 by 2. It's very clear. Compare this. It is minus constant term divided by the coefficient of x. In general, I'll write similarly, 0 of the general linear polynomial ax plus b, where a not equal to 0 will be minus b by a. This minus b is minus constant term divided by the coefficient of x. For all the linear polynomial of this type ax plus b, The 0 will be minus b by a, that is minus constant term divided by coefficient of x. So we can conclude that the only 0 of linear polynomial will be equal to minus constant term divided by coefficient of x. Let us find the relationship between the zeros and the coefficient of a polynomial. The polynomial is a quadratic polynomial. Let us have a quadratic polynomial, say p of x is equal to 2x square minus 8x plus 6. To find the zeros, take 2x square minus 8x plus 6 equal to 0. Now we shall find roots of this quadratic equation by splitting middle term method. We know factorization. Let us split the middle term, splitting middle term method. In this method, we should have two different numbers to get the sum and the product. Here the sum is minus 8 and the product is 12, because the coefficient of x square is 2 and the constant term is 6. We need to multiply them, that's the product. So we have to take two different numbers such that their sum becomes minus 8 and the product becomes positive 12. Which are those two numbers? They are minus 6 and minus 2. By adding we get as minus 8. By multiplying them we get positive 12. Therefore, I will write a given quadratic equation as 2x square minus 6x minus 2x plus 6 equal to 0. I have split the middle term. Minus 8x I have split into minus 6 and minus 2. In the first two terms we have 2x common, we get x minus 3. In the next two terms I have minus 2 common, we get x minus 3 equal to 0. Now we have x minus 3 as common, we get 2x minus 2 which is equal to 0. Further you observe 2x minus 2 can be taken common. Finally our equation becomes 2 times of x minus 3 multiplied to x minus 1 equal to 0. When will this equation becomes 0? It will become 0 for x minus 3 equal to 0 or else x minus 1 equal to 0, which means x value is 3 and 1, positive 3 and positive 1. Now let us find the sum and the product of these two zeros. What is the sum of zeros? Sum of zeros is 1 added to 3 which is equal to 4. It is same as minus of minus 8 divided by 2. What is this minus 8 in our equation? It is the coefficient of x. So it is minus of coefficient of x divided by coefficient of x square. Isn't it? Look at the product of zeros. Product of zeros is 1 multiplied to 3 which is 3. It is same as 6 upon 2. What is 6 in our given equation? It is the constant term. It is constant term divided by coefficient of x square. Let us consider one more quadratic polynomial and check whether the sum of zeros is minus coefficient of x by coefficient of x square and the product of zeros as constant term divided by coefficient of x square. Let's check it. So let me consider one more quadratic polynomial. Say p of x is equal to 5x square plus 14x minus 3. In this case, what is the product? Product is minus 15 and the sum is positive 14. We get this positive 14 by taking 15 minus 1 and we get product as minus 15 by taking 15 multiplied to minus 1. Therefore, using splitting middle term, I can express this as 5x square plus 15x minus x minus 3. In the first two terms, I have 5x common. I will be getting x plus 3. In the next two terms, I have minus 1 common. I will be getting x plus 3. In the next step, it becomes x plus 3 multiplied to 5x minus 1. Now if you equate it to 0, if p of x equal to 0, then x values will be minus 3 and positive 1 by 5. Therefore, this minus 3 and positive 1 by 5, they are the zeros. Let us now find out sum of zeros. Sum of zeros in this case is minus 3 added to 1 by 5. Let's simplify. LCM is 5. We get minus 15 plus 1, which is minus 14 upon 5. Look at minus 14. It means minus coefficient of x divided by 5 is the coefficient of x square. What is the product in this case? The product of zeros will be minus 3 multiplied to 1 by 5, which is equal to minus 3 by 5. What is this minus 3 in the given polynomial? It is the constant term divided by coefficient of x square. So what is the conclusion? We can conclude that the sum of zeros is the constant of we can conclude that sum of zeros is minus coefficient of x upon coefficient of x square, and the product of zeros is constant term upon coefficient of x square. Let us generalize this condition. If alpha and beta, these are the symbols, alpha and beta, be the zeros of a quadratic polynomial, ax square plus bx plus c, where a not equal to 0, then we can express ax square plus bx plus c as some constant multiplied to x minus alpha multiplied to x minus beta for some real value of k. This implies ax square plus bx plus c is k times of x square minus alpha times x minus beta times x plus alpha beta, which is nothing but k times of x square minus, you can take x common, we get alpha plus beta plus alpha beta. If the value of k is 1, then ax square plus bx plus c will become x square minus x times of alpha plus beta plus alpha beta. Compare the left hand side with the right hand side. We have a value as 1, b value as minus of alpha plus beta, c value as alpha beta. Sum of the roots is minus b by a. You can observe, if you consider minus b by a, we will be getting alpha plus beta. Product of the roots alpha beta is c by a. This is very important concept, because whenever we have sum and the product of zeros, we can actually construct a polynomial. We will further understand it while solving the questions. We shall see the relationship between zeros and the coefficient of a polynomial if the polynomial is a cubic polynomial. From the previous discussion, we have learned sum and the product. Now we shall take 3 zeros of cubic polynomial. So let me consider 3 zeros of a cubic polynomial as alpha, beta and gamma. Let alpha, beta and gamma are the 3 zeros of cubic polynomial The general form of a cubic polynomial is ax cubed plus bx square plus cx plus d, where a is not equal to 0. This implies, like the previous discussion, we will express this cubic polynomial as k times x minus alpha into x minus beta into x minus gamma. Let us multiply. We shall multiply the last two terms together. Rest all let us keep it as separate. So k times of x minus alpha into x square minus of beta plus gamma into x plus beta gamma. Now let us multiply this x minus alpha to each term in the bracket. So I'll get k times of x cube minus beta plus gamma x square plus beta gamma x minus alpha x square minus alpha times of beta plus gamma into x minus alpha beta gamma. Further, it is k times of x cube minus, if x square is taken common, I'll be getting alpha plus beta plus gamma times x square plus, if x is taken common, I will be getting alpha beta plus beta gamma plus gamma alpha times x minus alpha beta gamma. I can now multiply this value of k. I'll be getting kx cube minus k times of alpha plus beta plus gamma times x square plus k times of alpha beta plus beta gamma plus alpha gamma times x minus k times of alpha beta gamma. Compare the coefficients of x cube, x square, x and the constant term, both the side, left hand side as well as the right hand side. We get a value as k, b value as minus k times alpha plus beta plus gamma, c value as k times of alpha beta plus beta gamma plus gamma alpha, and the d value as minus k times of alpha beta gamma. Look at this value of b. B is minus k times of alpha plus beta plus gamma. So I can write minus b as k times of alpha plus beta plus gamma. This implies alpha plus beta plus gamma is minus b by k. If k is equal to a, it becomes alpha plus beta plus gamma equal to minus b by a. Similarly, alpha beta plus beta gamma plus alpha gamma will be equal to, this becomes c by k. Since k value I have taken as a, it becomes c by a, and alpha beta gamma is minus d by k, so it becomes minus d by a. So what can we conclude? We can conclude that the sum of zeros is minus coefficient of x square by coefficient of x cube. Sum of product of zeros taken two at a time as coefficient of x by coefficient of x cube, and the product of zeros is minus constant term by coefficient of x cube. The sum of zeros is nothing but alpha plus beta plus gamma. We have this result minus b by a. Sum of product of two zeros taken together, alpha beta plus beta gamma plus gamma alpha, as c by a. This is b, this third one. Product of zeros alpha beta gamma as minus d by a. This is for a general expression ax cube plus bx square plus cx plus d. You can observe coefficient of x square is b, coefficient of x cube is a, so minus b by a is coefficient of x square by coefficient of x cube. C by a, c is the coefficient of x and a is the coefficient of x cube. Minus d by a, d is a constant term and a is coefficient of x cube. Therefore, you must remember this: alpha plus beta plus gamma is minus b by a. Alpha beta plus beta gamma plus alpha gamma is c by a. Alpha beta gamma, the product is minus d by a. Sometimes there may be a question: make a quadratic polynomial with given zeros alpha equal to 5 by 2 and beta equal to minus 1 by 4. Let ax square plus bx plus c be a polynomial having zeros alpha equal to minus 5 by 2 and beta equal to minus 1 by 4. I am taking the general expression for a quadratic polynomial. Since sum of two zeros will be here, alpha is positive 5 by 2, so 5 by 2 added to minus 1 by 4. Let us simplify this. LCM is 4. If 4 is the LCM, the numerator becomes 10 and minus 1, which will be 9 upon 4. Product of zeros will be 5 by 2 multiplied to minus 1 by 4. We get it as minus 5 by 8. Generally, we express it like this: ax square plus bx plus c as some k times x square minus the sum of the zeros multiplied to x plus the product of zeros is minus 5 by 8. Where k is a constant. What type of constant is that? A real constant. This implies ax square plus 3x plus c will be k by 8 times 8x square minus 18x minus 5. This is the given polynomial which is having the root 5 by 2 and minus 1 by 4. That is, taking k value as 8, we get the polynomial eight x square minus 18x minus 5, which has zeros 5 by 2 and minus 1 by 4. Let us verify this result. Verification. We had got the polynomial as 8x square minus 18x minus 5. Let us factorize this. To factorize, I'll apply again splitting middle term. I'll split the middle term as minus 20x plus 2x. So I get 4x as common, 2x minus 5 plus 1 is common, 2x minus 5. Therefore 4x plus 1 multiplied to 2x minus 5. If you equate it to 0, if you consider this as a polynomial, say p of x, if p of x equal to 0, then either 4x plus 1 should be 0 or else 2x minus 5 will be 0. Then only the product will become 0. So the x value is minus 1 by 4 or plus 5 by 2. So we got the roots as minus 1 by 4 and 5 by 2. So our method is correct. So in general, you must understand, in general, any quadratic polynomial is given by k times of x minus alpha into x minus beta or k times of x square minus sum of zeros into x plus product of zeros. This concept you must keep it in your mind. This will help you to frame any quadratic polynomial whenever they give zeros of that particular polynomial. Suppose there is a question, make a cubic polynomial with given zeros, alpha equal to 2, beta equal to 1 by 3 and gamma equal to, this is and gamma equal to 1 by 2. You must remember, like the previous discussion, the cubic polynomial can be expressed as k times of x cube minus alpha plus beta plus gamma times x plus alpha beta plus beta gamma plus gamma alpha times of x plus alpha beta gamma, sorry, this is minus alpha beta gamma. How do we remember this? You observe how to remember this. There is alternate minus and plus, isn't it? After x cube there is minus x square term, x square coefficient and positive coefficient of x and negative constant. Alternately there is minus and plus, so you can remember this. Now what we need to do, we have to find out sum of the zeros and sum of product of two zeros taken at a time and product of 0. Let me find alpha plus beta plus gamma. In this case it is 2 added to 1 by 3 added to 1 by 2. What is the LCM? It is 6. So the numerator we have 12 plus 2 plus 3, which is 17 upon 6. This is sum of zeros. Sum of two zeros taken at a time, alpha beta plus beta gamma plus alpha gamma. This will be 2 times 1 by 3 plus 1 by 3 times 1 by 2 plus 1 by 2 times 2. Simplify this, we get 2 upon 3 plus 1 upon 6 plus 1. This will be 6 LCM, 4 added to 1 added to 6, 11 upon 6. This is sum of two zeros taken at a time. Now product of the zeros, alpha, beta, gamma, will be 2 multiplied to 1 by 3 multiplied to 1 by 2. This 2 and 2 get cancelled, we get it as 1 by 3. This 1 by 3 is the product of zeros. Therefore, the required polynomial, cubic polynomial, is k times x cube minus 17 upon 6x square plus 11 upon 6x minus 1 by 3. Look at this. Throughout you can take 1 by 6 as common. So we'll be getting k upon 6 multiplied to 6x cube minus 17x square minus 11x minus 2. Therefore, the required polynomial is 6x cube minus 17x square minus 11x minus 2, where k is positive 6. This particular cubic polynomial will be having the zeros as 2, 1 by 3 and 1 by 2.